jokes or anything like that? Yeah. All right. Okay, this one's for Gwen. Okay, with your ruler, here's what I need you to do first. We're going to develop the distance formula. I need you to draw a coordinate plane. Now, mine's way cooler than yours, but, you know, one day you will all have these too. That day is just sadly not today. All right, so go ahead, take 2 seconds, and use your ruler to draw a coordinate plane. All right, it looks something like this. Of course, the coordinate plane is just the intersection of two real number lines at the point 0, 0. All right, and whatever works for you, depending on how big your graph paper is. I'm gonna go every 2 squares on mine to give me these little marks here, to sort of scale out my x and y axes. You do whatever works for you on your graph paper. And okay, I'm gonna show you something. I don't want you to copy this down. Just watch, okay? Just watch. In a red pen here, I want you to show you something here. I'm gonna put a point right here, okay? That's not red. I'm gonna put a point right here. And then I'm going to put another point right here, okay? And I'm going to draw a line from here to there with my 2 points, okay? Don't do anything yet. You're just watching. If I was going to number this off, this would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, great. Can someone tell me how long is that line segment that I just drew in red? Go and tell me. What do you think? Yeah. He says 8. 8 units. What do you think? It's 7 units. Any other guesses? What do you think? You say 8 units. Good. Good. Okay, let's hear. Did you guys count? Okay, here, count with me, right? So this is 1, 2, 3, 4, 5, 6. Isn't that 7? Did I do that right? I mean, that's 7 units long, right? Okay, yeah. Okay. Ooh. Emily just hit on something. Emily, so how many of you counted? Raise your hand if you just counted the line segments. 5 or 6 of us. Okay. Is there another way to do it? Emily, what did you just say? Yeah. Isn't this distance just how long it is, which is at 9, minus however short it is, which is 2? So isn't this whole thing just 9 minus 2? You guys agree with that? Who agrees with that? Put your hands up. Okay, good. Let the record show everybody's hands are up. That's the slick way of doing it, okay? And let's do another thing. I'm in blue here, all right? I'm going to put a dot right, I'm going to put a coordinate point right here, okay? Right there, okay? And I'm going to draw a line. Oh, cheapers. That's not right. Try this again. I'm going to go, all right? And I'm going to go all the way down here, and I'm going to ask you the same question, okay? How long is that blue line segment that I just did? Go ahead, think about it. Think about it. Oh, yeah, sorry, I'll number for you. Yeah, 1, 2, 3, 4, 5, and 6, okay? All right, who's got an answer? How long is that blue segment? Oscar. It's 4 units. How did you do that? He said 5 minus 1, and that gave him an answer of 4 units. You guys cool with that part? Okay, good. Now, if I were to draw, say, in black or something, right? If I were to draw the distance from my red point to my blue point, that's the thing I'm looking for, right? That's distance between the red and the blue points, okay? Does anyone notice what I'm drawing here? What am I drawing? I'm drawing a right triangle. And what do we know about right triangles? A squared plus B squared has to equal C squared. Okay, great. Great. Here's what I want you to do. I want you to erase, if you haven't done anything yet, okay, I want to erase all these numbers here, okay? And I'm going to erase these. Keep in mind what you just did, 9 minus 2 and the 5 minus 4, okay? Now, I'm going to ask you, we're going to put a coordinate here. I'm going to call this point A, okay? And point A, you can copy this part down, is at a general coordinate x1, y1. So we have now taken away the actual numbers, and we're putting in generic points. All right, generic points in there, x1, y1. Now over here, up in my blue dot, we're going to call that point B, and we're going to put in generic points x2, 2. All right? And I want to challenge you and ask you the exact same questions. How long is this line segment that I just highlighted in yellow for that? And you can't say 7 anymore because we don't know what it is. How long is that in terms of what's on the page? Anybody got it? Yes, thank you. Oscar says it's just x2 minus x1. right? It's the furthest point away minus the closest point away, x2 minus x1. I'm going to ask you the same thing. What is the length of this blue line that I am highlighting right now? Yes, go ahead. y2 minus y1. Very good. And the distance, the thing that I'm looking for, is the distance from A to B. So we're going to take advantage of the Pythagorean theorem here. So the distance squared has to be A squared plus the B squared. That's the Pythagorean theorem, right? So the distance squared, what is the length of A, the yellow line? What's the length of the yellow line? You got it. x2 minus x1, and the formula says to square that. Plus, what's the distance of the blue line? y2 minus y1, and the formula says to square that. So notice that I'm just taking advantage of the Pythagorean theorem. I'm just calling it different things, right? Instead of calling it A, I'm just calling it a distance of x2 minus x1. Now, I don't want distance squared. I want the actual distance. So how do I solve this for D? What do? You got it. I'm going to take the square root of both sides. And you know what, ladies and gentlemen? You have just derived the distance formula. The square root of the quantity x2 minus x1 squared plus y2 minus y1 squared. And this is the distance formula. And you know what, you guys? You basically just did a proof. Oh, snap. I tricked you into doing a proof. Okay, so we have just derived the distance formula. We have the distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, a couple things I want to note about the distance formula. The distance formula actually tells you a length in units. It tells us a length in units. Okay, that's going to be important later. So a little side note, the distance formula tells us a length in units. Okay, I'll talk about that later. Let's do an example together. We're going to find the distance and we're going to graph. I'm going to give you 2 points. The 2 points I'm going to give you are point A, which is at 3, 6, and the point B, which is at the point -1, -4. What we're going to do is we're going to set up a coordinate plane. We're going to take a guess as to what we think the distance might be, and then we're going to actually solve and see how close that we were. All right? So what we're going to do is we're going to take our ruler and we are going to draw a coordinate plane. Now, where is point A? Is it in quadrant 1, 2, 3, or 4? Point A. It's in quadrant 1, yes. And how about point B? Where's quadrant B? 1, 2, 3, or 4? No. Try again. I mean, sorry, 3. You're right. Just keep you on your toes. All right, so I'm gonna draw a coordinate plane 1, and I'm gonna highlight quadrant 1, and I'm gonna highlight quadrant 3. And make sure you give yourself enough room. So I'm going to move mine down just a little bit here and make sure I give myself enough room. Okay, again, this is the x-axis. It represents the real number line. This is the y-axis. It represents the real number. I'm going to go every 2 units on mine. You go what works for you. Works for me. Isn't there a rap song that says that? Like a P. Diddy song? Isn't there a P. Diddy song that says that line? You do what works for you. I do what works for me. I swear that's a song. Maybe not. Okay, maybe I'm not. Alright, I gotta extend this down a little bit. There we go. Bump, 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 bump. There we go. So let's put point A on the graph here, 3, 6. So point A is going to be 1, 2, 3, 1, 2, 3, 4, 5, 6. Is this the right spot? Everybody check me out. Is that the right spot? Is that A? Okay, let's go -1, -4, -1, -4. So I think that's right here. Check out, is that the right spot for B? Did I do it right? Yeah. Okay, good. Now, when you're done that, take your ruler and connect your line segment. So it should look something like this. And then we're going to take a guess as to how long we think that line segment is based on the scale that's given to us on our page, okay? So based on the scale, we're going to take a guess, and we're going to see how many. Have fun. All right, let's take some guesses. Give me a guess. Someone shout it again. Yeah, 10. Let me go higher than 10. Yeah, 12. Anybody go higher than 12? Yeah. 16. Anybody go higher than 16? Okay, so we think our guess is somewhere between, so 16 is the highest. Okay, good. Give me a low bound. What's a low bound? Anybody guess low? 9. Anybody go lower than 9? 8. Lower than 8. 8. Anybody go lower than 8? So we think our answer, our length is somewhere between, I'll call this D, right? And somewhere between there, 8 and 16. Is that a reasonable range for us? All right, good. Here we go. Let's go ahead and figure it out using the distance formula. Now remember, we're just taking advantage of the fact that we have a right triangle here, and we're just using Pythagorean's theorem in a more sophisticated way. So here's what you need to do. First, you got to say to yourself, okay, I need my first x and my first y. And I want you to say that to yourself in your head, out loud, actually. So go ahead, write down first x, first y. Go, say it. Okay, say it again, because I didn't hear you guys. Say it again.
First x and first y.
Good. Now let's figure out second x and second y. Second x, second y. Say it. Go ahead. Good. Good. Then we're going to write down the distance formula. The distance is equal to the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Notice that the square root is positive because we're speaking of positive lengths in the coordinate plane. So what is the value of x2? You labeled it. What is it? -1. Good. Minus, what's the value of x1? 3. Good. And what do we do with all this stuff? Square it. Good. Add that. What's the value of y2? -4. Minus, what's the value of y1? 6. And what do we do with all this stuff? Square it. Good. Distance is the square root of, this is -4 squared. How much is that? 16 plus, what's -4 minus 6? 10 squared is 100. So I'm looking at the square root of 116, which is approximately, on my calculator here, square root of 116, 10.8. 10.8 what? Monkeys? 10.8 what? Oh, units. Okay, units. All right, good. 10.8 units. Hey, is that within our reasonable guess?
Yes.
It sure is. So we are probably on track. Part of our day here, we're going to talk about the midpoint formula. All right? If I told you guys this, if I said, hey, yes, the distance between here and Windsor is the McDonald's on the corner, would you think I was smart or not so smart? Not so smart, right? Why? What did I tell you? What did I tell you? The distance between here and Windsor is the McDonald's on the corner. What did I tell you? I told you a location, huh? And that's the difference between the midpoint formula and the distance formula, okay? The distance formula tells you an actual length in units. The midpoint formula gives you a location in the plane. So if I said to you this, the distance between Hillsburg and Windsor, the midpoint between here and Windsor is the McDonald's on the corner. Now it makes sense in the context of what I'm saying, all right? So the midpoint formula, people mess this up all the time. The midpoint formula tells you what? Tells you a location. A location in the coordinate plane. That is important, all right? So if I ask you for the midpoint and you give me 9 units, I want to know you have no idea what you're talking about, okay? So the midpoint formula gives you a location in the coordinate plane. All right, let's talk about how we get it. All right, so give yourself a short little coordinate plane here, highlighting quadrant 1. Highlighting quadrant 1. All right, I'm going to put a point right here. And I'm going to put a point, well, that's not right. I'm going to put a point right over here. And I'm going to ask you how long you think that line segment is. How long is that line segment? How long is that? How long is that, you guys? You guys don't seem confident. How long is that? It's 6 units long, right? This is 6 units long. Okay. Okay, sorry. Here you go. You guys happy now? Good. You guys keep me honest. 6 units long. Okay, good. If I ask you, where is the midpoint? Then where's the midpoint? What would you say? It's 3 units long, right? That'd be right here. This is definitely the midpoint, right? Yes. Sorry, I should have told you that. This is definitely the midpoint, okay? The midpoint is 3. So how do we come up with the midpoint being 3? How do you know that 3 is in the middle of 0 and 6? It's half of the total. Good. Very good. Half of the total. So to get the 6, we did the starting point, which was 0, plus the ending point, which was 6, and we found the average of it, which was divided by 2, which gave us a location of 3. And in fact, that's exactly how we find midpoints. We take the average of the locations, start and end, and plot it on the coordinate plane. So the midpoint formula looks something like this. Take the average of the x's, x1 plus x2, divided by 2, and the average of the y's, 1 plus by 2, divided by 2. And note that this is an x, comma, y location in the coordinate plane. So the midpoint formula tells you where something is on the coordinate plane, and namely, it tells you exactly the center of a segment. And we find it by averaging 2, 5. Okay, so we have 2 points. We have point A and we have point B. Point A is at 4, 3, and point B is at negative 2, 5. Which quadrant is point A in? Quadrant 1. Good. Which quadrant is point B in? It's in quadrant 2. Very good. So I get to draw a coordinate plane that highlights quadrant 1 and highlights quadrant 2. Does that make sense, you guys? All right. And you can do the same. So check it out. I've got a coordinate plane now that is highlighting quadrant 1 and quadrant 2. So 1, 2, 3, 4, 6. That's 6 units. 1, 2, 3, 4, 5. There's 6 units. 1, 2, 3, 4, 5. There's negative 5 units that way, and then I'll just go down negative 1. Okay, so here's my highlighted quadrant. Again, this is quadrant 1 over here, and this is quadrant 2 over here. Since A is in quadrant 1, I'm going to go over 4 and up 3, and I'll do that in red so we can see it. Go over 4, 1, 2, 3, 4, up 3, 1, 2, 3. This right here looks like point A. You guys with me on that part? Yeah? Okay, B is in negative 2, 5, so negative 2, 5 looks like I'm going to be right here. All right, and here's point B. Once you got all that down, I want you to take your ruler, draw a nice line segment next from B to A. What we're going to do is we're going to guess where we think the location of that is. Now remember, when you take a guess, you're giving me a coordinate. Tell me. You goofball. Okay, apparently I mixed up my... So B's not right there, is it? B's up... Hey. I'm human. Jeez Louise. Okay, so let me adjust my line. Okay, there we go. There we go. Aha, there, it's all good. Now, okay. For someone who has not yet done the math, what's our guess going to be? Our guess is 1, 4. Good. I'm so glad that you're giving me a location. 1, 4. So an X and a Y. All right, so let's see here. The midpoint formula says I got to add the X's together, divide by 2, and then add the Y's together and divide by 2. That's the average. So the X values, remember, this is my first X, this is my first Y, this is my second X, this is my second Y. So what's the value of X1? So 4 plus a negative 2 divided by 2, comma, what's the value of Y1? 3 plus 5, all divided by 2. And that looks like 2 divided by 2, which is 1, and 8 divided by 2, which is 4. Oh my gosh, you were totally right. So if I go over 1, I go up 4. Check it out. Right there is exactly the midpoint. All right, what do you guys think so far? Easy, medium, or hard? Easy? All right, questions, comments, concerns, jokes, judgments, opinions. Any of those?